So whatever we have discussed so far, the same thing has been depicted here as a picture, and it is IP security architecture. So as I told you, it has two databases, SAD, Security Association Database, and Security Policy Database, SPD. So these are the two databases which help here for having the destination address and other important informations. So when you look into this, Security Association Database is associated only with IP security version 3, and here also security association with IP section v3, whereas SPD is associated with IP security version 3 as well as for key exchange. So security policy is associated with both the bodies, and IKE is internet key exchange version 2. So the internet exchange happens here. So this is the IP security architecture. Now let us understand what is the functions of security association database. So it is identified by an index, and it also tells which is the head, which is the protocol being used, like this. So those parameters are defined already well in advance. Now security association database is normally defined by those parameters, and here in detail we will have the discussion about the parameters. First one, security parameter index. I told you it is an unsigned 32-bit number. So this value is necessary to identify the security association. For outbound SA security association, the SPI security parameter index constructs the packet's authentication header or ESP header. For inbound incoming messages, it is used to map the traffic to the appropriate SA. So for any message which is going out from one network to another network, this SPI constructs a packet, and that SPI constructs the packet's AH or ESP header. So authentication it will check, and it will also check for the encapsulated message. For the inbound security association message coming to the association, it checks with the traffic. Similarly, you have the second parameter, which is called as sequence number counter, a 32-bit value to generate the sequence number field in AH or ESP headers. So every packet is going out, and you need to have a track of that. So that is associated to a counter. By default, it gets updated on its own. So the sequence number gets updated on its own, and that is a 32-bit value. The counter value is a 32-bit value which is used to generate the sequence number field in AH or ESP headers. Next we have sequence counter overflow. It is a flag to indicate overflow of sequence counter. So once the last whatever is the limit of the counter, if it has reached, it has to either shift to 0 or it has to go to off. So that is called as overflow parameter here. So it is whenever it reaches to the maximum value, an overflow message pops up which generates auditable event and prevent further transmission of packets. So immediately when this flag becomes highlighted, or when this overflow flag is high, the actual procedure of transferring the packets is stopped. Next we have anti-replay window. Determines whether an inbound authentication header or ESP packet is a replay. Anti-replay. So particularly it is checking whenever we have already discussed, whenever we have replay of messages, it is normally monitored and it is abruptly rejected. Same way, there is a window which is monitoring the anti-replay window, determines whether an inbound coming towards the association database, whether the AH or ESP packet is a replay or not. If it is a replay, it is immediately abandoned, it is discarded. AH information, authentication header information, information on authentication algorithm. What is the algorithm you are using? Three types I have told you. You have digital signature algorithm, you have hash algorithm, you have HMAC algorithm. So which is the algorithm used? What are the keys used? What is the duration of the key lifetimes? Now we have very commonly the OTPs, one time password, which is short lived. It can be 10 minutes, 20 minutes, half an hour. So what is the duration of this? And related parameters used with AH. So all the information related to AH is known in this, and that is associated with the database. So database will also have this information. At the same time, it will also have ESP information. What is the payload, to whom it is going, what is the header, what is the tail, etc. So ESP information on encryption and authentication algorithm, keys, initialization values, key lifetimes and related parameters being used with ESP. Yes, very much clear with this. Lifetime of the security association. For how long? What is the duration of the security association database? How much time it is going to exist? SA terminates and is replaced with new SA after certain interval or byte count. So until and unless the packets reach some vaguely, the calculation is made and it will be alive till that count reaches to that maximum level. The moment count reaches to that maximum level, it is considered as discarded and it is a new security association has to come. So this also terminates. IP security protocol mode. What mode are you using for IP security? Whether it is transport mode or tunnel mode. We have seen this. The third type is the wildcard. Randomly it goes on. So in case we have this term associated next, we will understand what is wildcard. Tunnel we know. Transport we know. Transport is using the transport layers and it undergoes the transport protocols. Tunnel has no such protocols and it has no security check also. It will not go into the gateway or to the router or the firewall. Path MTU, maximum transmission unit, a path where maximum size of packet can be transmitted without fragmentation. So where is the path where maximum amount of transmission can happen without any cut in the information? So these are few parameters associated with security association database. So we now go with the second policy database, which is security policy database, SP or SD or SPD. The means by which the IP traffic is related to specific SAs is the security policy database. So if ever you have any IP traffic to be connected to security association, it has to pass through security policy database. So this contains entries, who came, when did they come and all such information, which defines a subset of IP traffic and points to an SA for that traffic. So all the information is present in this security policy database. It is also defined by a set of IP and upper layer protocol field values called selectors. So there are selectors in this security policy database which identifies the protocol field values. Selectors are used to filter outgoing traffic in order to map a particular SA, and they come in handy whenever the traffic is going outside. So when they are going outside, it checks whether right information is going out from this particular network. General sequence of each packet. Compare the values of the appropriate fields in the packet, which will point to 0 or more SAs. So how exactly each packet does? So it checks with the appropriate fields in the packet, selector fields, and that selector field will point to 0 or it will be to n number of SAs. So find SA for packet if it exists and its associated SPI. If it is 0, you have to no worry. But if it is having a number, which is that security association? So find out for that particular association, and if it exists, if you know that it is identified by an unsigned 32-bit number. So find out what is that security parameter index. So find out what is the SPI. Do the required IP processing. Then after you have identified where it is to go, the destination you have found out, you do the necessary processing of incorporating the authentication header and the ESP processing, ESP encapsulating payload. So this has to be done before the packet goes out from one particular network to another network, and this is taken care by security policy database through security association. Following selectors determine an SPD entry. So remote address may be a single IP address, an enumerated list or range of addresses, or a wildcard address. Wildcard address is masked. Nobody knows who it is, but one point of time it will be revealed. So the later two are required to support more than one destination system. So what is the work of the selectors? Following selectors determine an SPD entry. What is it is checking? Who is coming for the security policy database? remote IP address it will check. So what is the IP address, from whom it has come, and what is the range of addresses it will check. It will also check for local IP address. This local IP address may be a single address, only one within the network, or an enumerated list of range of addresses or wildcard addresses. The latter two are required to support more than one source system. So this is also the information present by SPD. Next layer protocol, the IP protocol header, that is the next layer, IP version 4 and IP version 6, includes a field that designates the protocol over an IP. This is an individual protocol. So this also is checked by SPD. It also identifies the name, a user identifier from the operating system. This is not a field and is present if IPSec is running on the same operating system as the user. It will also identify a name given from the operating system. Local and remote ports. These may be individual TCP or UDP port values, identification of the ports, or a numerous list of ports or a wildcard port. All these information is present in the SPD entry. Now we understood something, we tried to understand something called as IP traffic processing. So how the traffic happens in internet protocol layer and how it is processing. Basically, there are messages which is going away from the network and one which is coming into the network. Therefore, the messages are in the form of packets, and therefore it is commonly called as outbound packets and inbound packets. IP security is executed on a packet by packet basis. So before transmitting and receiving to next higher layer, the IP packet is processed by IP security logic. So before going on with the next level, we first need to understand what do you mean by outbound packet and inbound packet. So this diagram depicts what do you mean by outbound packet. So an outbound IP packet, example from TCP UDP, that is from the transport layer. From the transport layer it comes and it is falling on the IP layer. In the IP layer, first it will go along with the check with security policy database, SPD, checks, and if the information is present here, it is retaining, it is going further. If the information, no identity as such is there, it will be discarded. So if no identity of this information is present, it will be discarded. So first check for unauthorized user, unauthorized messages. If it is coming, it will be discarded. If it is found, it is there, it determines which policy. It is determining which policy. So should I protect the policy or should I ignore or should I discard? So three chances are there here. So if it is going to protect, it does something. If it is going to bypass, it will do something. If it is a waste, even then it will be discarded. So the packet, the information is further sent for two stages. One is protect and one is bypass. Bypass, it is already protected. You need not have to do the security check of protection. It is directly bypassing all this procedure and going to the next stage. So the next stage is forward IP packet via IP. So send it for the next processing. It is already checked. If it is not checked, it goes to this rigorous procedure of check, and that is done in a process called as protect. What it does? So the information, packet information is sent into the security association database. Again here, if the message is found here in the database, it is going for the next stage of processing. Otherwise, it goes for internet key exchange. For some reason it is not having the key. Then along with the key, it again checks. So there is a policy that if the key is associated, then it is a valid information and it goes for next processing of authentication header protocol and ESP protocol, and if that is a success, it goes to the next stage, which is forward packet IP via IP. So forward this packet to the next layer, IP. So this is an outbound packet, which means the message is coming from the transport layer to the IP layer. What exactly outbound packets mean? A block of data from the higher layer like TCP to IP layer, and IP packet is formed consisting of a header and body. We have already discussed from the diagram, from the block diagram. IP section searches the SPD for a match to this packet. If no match is there, it is discarded. If the match is done, if it is found, processing is done. How the processing is done? It is first done in the policy database. again there, if the policy for this database is discard, then it is discarded. If the policy is to bypass, that already checked and other things has been already done, it is going to the next stage. So same thing has been discussed here. And if the policy is protect, then a search is made for the security association database for a matching entry. Again there, if it is matched, it is going for the next process. If it is not matched, key exchange is done. And after doing the key exchange, it is again checked. Then probably the keys and the information is linked, and therefore it goes for the next stage. So byte by byte, bit by bit, every information is cross-checked. Matching entry in the SAD, Security Association Database, determines the type of the processing for packet like. So what do you want? Encryption you want, authentication you want, or both, or do you want to use transport mode or tunnel mode? So then the packet is forwarded to the network for next process of transmission. We have seen the outbound packets, that is the packets which are coming from the transport layer to the IP layer. Now let us understand what you mean by inbound packets. An incoming IP packet triggers the IP section processing. So within the IP layer, you have the packets to be processed. So that is called as inbound packets. So following steps occur. What is it? IP security determines whether it is an unsecured IP packet or the one that has ESP or AH headers by examining the IP field or next header field. Just now we saw. If it is required, normally it goes for ESP and header authentication header protocols. So every time it will check. So it will definitely be having that. If the packet is unsecured, but it is already secured, right? It is done. If the packet is unsecured, it searches for the SPD. If the bypass policy is there, then IP header is processed. And once it is processed, it will remove the upper layer and the inner body is delivered to the next layer. If the policy is protected or discarded, then there is no match, then the packet is discarded. So for a secured packet, IP security searches the SAD, Security Association Database. If no match, then the packet is discarded or appropriate ESP and AH processing is done, and the IP header is processed and stripped off, and the packet body is delivered to the next higher layer such as TCP. So within the IP layer it is processed and it goes to the transport layer. This is how inbound packets work. So initially you have the inbound packet from internet, packet type. Alright, it checks for the IP security protocol. It checks here in the Security Association Database. And only in the IP layer it checks with the Security Policy Database. If no need to check and all such things, it is bypassed and it is going to the next higher layer. If no bypassing has to be done, it has to undergo a check. So what is that check? It checks in the association. If it is not matched, it will be discarded. If it is matched, if the match is found in the Security Association Database, it will process using authentication header and ESP, and the packet is enclosed or encapsulated with AH and ESP, and then it is delivered to a higher layer, and the higher layer here is the TCP or the UDP protocol. Next, how do you encapsulate the payload? Encapsulating security payload. ESP can be used to provide confidentiality, data origin authentication, connectionless integrity, anti-replay service, and limited traffic flow confidentiality. So the advantage of going for encapsulating security payload is it provides everything: confidentiality, originality, authentication, integrity, anti-replay service, and limited traffic flow. So definitely it is considered as an advantage of using encapsulating security payload. And this is how the packet looks like. So initially the ESP packet is of 32 bits, and that 32 bits, you also remember we had SPI, which is a 32-bit number. So that 32-bit number parameter SPI is also below here, and within that you have the sequence number, and within the sequence number you have the payload. So we can just consider these two as like and header. So parameter index, to whom it has to point, what is the sequence number, and below that you have the original message. And if required, padding has to be done. So what is the pad length and what is the next header, that is decided as per this packet. integrity check value ICV, so that it is not tampered. Therefore, this is how the ESP packet format looks like. Let us understand what are these numbers or what are these uh, parameters present inside the packet. First one, security parameter index, which is a 32-bit number. It identifies a security association. Long time back we had a security association is identified by its SPI, to which association it belongs to, or in other words to which network it belongs to. Next is sequence number. It is similar to a counter, provides an anti-replay function. So counter cannot come back again and again. It always goes on in one direction by incrementing. Therefore, the sequence number is nothing but associated a number with a counter. And as a result, when you are linking it to a counter, replay is avoided. Payload data. This is the transport level segment or IP packet that is protected by encryption. So all this is protected, it is encrypted, and this is your original message. What do you mean by padding? So padding is either adding the bits on the right direction or the left direction in order to make it of a right length, and it is 255 bits, 255 bytes. So the purpose of this field is discussed later. The particular intention of padding is to bring it to whatever is the desired length. Next header identifies the type of the data contained in the payload field by identifying the next header in that payload. So in this payload there is a header. So next header identifies the type of data contained in the payload field by identifying the first header. It identifies what is the header present here, and this header information will tell you what is the type of the data present inside the payload. So you can look out for next header. Next header is always pointing out to the next message identification, what exactly it is all about. Integrity check value, a variable length field of 32-bit words that contain the integrity check value computed over the ESP packet minus the authentication data field. So number one, it is a variable length field. It can vary, and it is a 32-bit word. Basically, it is meant to check the integrity of the message. So after looking into the format of the packet, we'll now understand what exactly is present inside that. When any combined mode algorithm is employed, not necessarily that only one algorithm has to be implemented. You can use a combination of algorithm. Then decrypted plain text may fail, and as a result integrity check is done. So when you are not knowing which is the algorithm you are using, a pass or a fail indication for the integrity check is got. So you will know whether it has passed through this check or not. Then integrity check will appear at the end of the ESP packet and it will be omitted. So ICV is not necessarily a mandate. It can be ignored also. Now the algorithm encodes with payload data and ICV equivalent means of verifying the integrity of the packet. So if you have used a different kind of an algorithm and if it is not able to pass that particular thing, then the integrity check is lost. Therefore, you can ignore and you can use a new algorithm, new ICV. Integrity check can be done again, and as a result the packet is checked. So this is how the substructure of payload data, extended version of this diagram. Two additional fields are present in the payload. If you look into this, this remains the same. Security parameter index, it tells the name of the security association database. Sequence number, which is a counter, which helps in tracking the packets as well as avoiding replay. Next we have initialization value. So I told you this is necessary for a process to begin. Nothing is there, some random bit has to be considered. So initialization value or nonce, it is a temporary number, is present and can be used for encryption or authentication used in ESP. So to begin with, you have to start with something. Okay, so that something is initialization value. And next you have the payload and TFC padding. So what is TFC padding? This is padded after the payload data and before the padding field if tunnel mode is used. So if you are going for any other, this is the actual padding, 255 bytes. If you are going for tunnel mode, you have to use this TFC padding, which is optional and it is before the actual padding. So once this is done, your data is ready for transmitting. It is going for outside network. So this is the version of ESP. Yeah, we are to begin with this topic, which is called as encryption and authentication algorithms. That means which are the algorithms which we are going to use for encryption and authentication in this particular topic, which is with respective to IP. As we all know, the payload, which is the data or the message, the payload, padding, pad length and next header files are encrypted by the ESP service. So what is ESP? We know that encapsulation service payload. So all of the data are encapsulated within a package. And when you are encapsulating, you require the encryption. So all this content, so it is in a shell. So the payload, which is the data, along with the padding done and the pad length, whatever is the pad length and whatever are the header files, these are all put into a single box after encryption. So this is called as encapsulated service payload, and this is the service offered. So in that case, we need to have a algorithm for encryption. So if the algorithm used to encrypt the payload requires cryptographic synchronization data such as an initialization vector, then data is placed in the beginning of the payload field. That means most of the time we need to do the encryption, right? Encryption is done with the key and the plain text. So we have the plain text, which is the payload. We don't have the key. In that case, how will it start with the encryption process? How will it begin? So the initialization vector comes into picture. As I've already told you many times, initialization vector is nothing but a combination of bits. So it is a random, pseudo-random sequence. So this will be considered, and with this the encryption will proceed with the plain text, and then it goes on. Then the next round, so this happens in the beginning, in the first round. If there are multiple rounds, as we are aware now in encryption, there are multiple rounds, which is the strength of the encryption algorithms. In multiple rounds, in the beginning we require an initialization vector. As we go on with the consecutive stages, it's not required. They themselves act as the inputs. So in that case, initialization vector is required. If included, an IV is used. IV is usually not encrypted. So if we are using, initialization vector is taken as it is. So initialization vector is computed after the encryption is performed. So using the initialization vector, we are performing ICV. So this is got after encrypting. So the order of processing helps in rapid detection and rejection of replayed or bogus packets by the receiver. By doing so, most of the packets which are replayed or most of the packets which are bogus, these are unnecessarily not included. These are avoided. They get avoided by doing this process. Hence, the impact of denial of service attacks is reduced. By doing so, a main particular attack, which is called as DOS, denial of service. So please remember, when you are doing encapsulation service protocol payload, in that case, the denial of service attack is completely avoided or it is reduced. Also, it allows for parallel processing of packets at the receiver, that is, decryption and integrity checking occur in parallel. Along with this, because it is very fast, we need to have a rapid sending of data and receiving of data. There should be no delay there. Therefore, parallelly things happen. ICV is not protected by encryption, so an algorithm must be used to compute the ICV. We have not got it. It's only the initialization vector that gets encrypted with the plain text. But after doing encryption for the initialization vector, we get ICV. This has to be, this has not been protected. So we need to have a other algorithm to protect this. Next, what do you mean by padding? So we already know the importance of padding. Padding is making the length to the desired length. If padding is done to the particular message, it just enhances the length of the message. So padding field serves several purposes, of which, if an encryption algorithm requires the plain text to be a multiple of some number of bytes, then the plain text expands to that size by padding. As I told, if you want to expand the length of the plain text, length is to be increased, then it is done by padding. This is the one service provided by what is called as padding. ESP format requires the pad length and next header fields to be aligned within the 32-bit. So the ciphertext must be an integer multiple of 32 bits. So padding field takes care of this. So whenever we are doing bringing the content, like what is the ESP, what is happening in ESP, it is the message, it is the padding, it is the padding length, it is the header fields. All these are put into one shell. So when you are doing so, it should be of a 32-bit word. It should be aligned to that particular format. If so, if it is not happening so padding will take care to add on with the extra bits. Along with this, additional padding may also be added to provide partial traffic flow confidentiality by concealing the actual length of the payload. Definitely. So when you're doing so, nobody knows what is it is sent into a standard format of 512 bits or 64 bits. So in that whole of this thing, we don't know what is the length of the message. So the length of the message is actually hidden. It is concealed. So this provides one kind of confidentiality, and this is helpful. So we have understood about padding. Now we'll understand about anti-replay service. So a replay attack is one in which attacker obtains a copy of an authenticated packet and later transmit it to the destination. So this may disrupt the service. So we know replay, sending the same message again and again. And authentication copy, original copy is taken by the hacker. He somehow steals that particular information and he sends it again and again to disrupt the service. And as a result, it would have given a wrong result. It gives undesired consequences. So sequence number field is designed to avoid such attacks, So each and every message packet which you are sending will be given a number, and that is called as a sequence number. So that will to one extent allow the packets not to be sent again and again. Same number of packets will be avoided. So the replay can be avoided. Study is analyzed as generation of sequence number. How do you generate? What if the hacker only does the same thing? He is only generating the sequence number. So how to generate the sequence number? So this is one of the confidential task given by the organization or any person or a service provider to take care about the sequential number to be generated. Next, after you are getting the sequence number, processing of sequence number by the recipient. Recipient should know which sequence, because nobody will follow 1, 2, 3 or ABCD. There will be some other sequence, and that is the code again. Because everybody is knowing 1, 2, 3, 4 ABCD, they will be able to get to know about this information. As a result, there is another way or a sequence which is hidden and which has to be shared with the recipient. So that is another task, that is another work to be done. So when a new SA is established, sequence number is set to 0. Each time that a packet is sent on this SA, the sender increments the counter. We have seen this already. Security association, whenever a security association is established, sequence number is set to 0 and we have set a counter there. So counter will automatically increase, and as a result that will give the sequence number. Each time a packet is sent on this SA, the sender increments the counter and places the value of the sequence number field. It will be placed there. Thus the first value to be used is 1. If anti-replay is enabled, the sender must not allow the sequence number to cycle past 2 to the power of 32 minus 1 back to 0. So this is 2 to the power of 32. In that case, this is 2 to the power of 32. Whenever that means it should stop the counter once it reaches to the bigger number 2 to the power of 32 minus 1. Immediately the counter should stop. It shouldn't go back to 0. It becomes very easy to do the replay attack then. It should give a message as overflow or any beep signal telling that it has crossed the limit. Otherwise, there would be multiple valid packets with the same sequence number. If the limit of 2 to the power of 32 minus 1 is reached, the sender should terminate this SA and negotiate a new SA with a new key. So these are all the sequences which has to happen, and it is taken care by the softwares. So next, how to generate the sequence number. When a new security association is established, sequence number is set to 0. Yes, just now we have discussed. Each time a packet is sent on this SA, the sender increments the counter and places the value. Yes, this is also done. The first value is 1. If anti-replay is enabled, the sender must not allow the sequence. Yes, this we have seen this so far. So all these precautions are taken care. If it is reached to the limit of 2 to the power of 32 minus 1, then the sender should terminate this and he has to go along with the new security association, and that is taken care.